And got a little background music going. And we are closing up the section with arcs, chords, and angles. Oh my. Arcs, chords, angles, oh my. Okay, a little play on a... Oh, whatever. Let's go. Arc. We have, first of all, define what is an arc. An arc can be thought of as a part of a circle. The official definition is all the points that are between 2 points on a circle. So there you have 3 examples of arcs, yes? Now, if you'll notice, you could go either direction when you go between the 2 points. So we need further definition of which one is the arc that we're referencing. Hold on to your pants. That's coming up in just a moment. All right. Central angle. The vertex of a central angle is on the, not the circle, careful, on the center, right? So the vertex is there. It cuts off or intercepts an arc. Man, should have been doing music the whole time, huh? Minor arc. The points are inside. Inside what? They are inside the angle, the central angle. Yeah? So notice we could have been talking about the points out here, but those are not inside the central angle. All right. It is, by the way, less than 180 degrees. More on that in a moment. And we always describe it with dos letters. Major arc. These are not points that are inside the central angle, but they are outside the angle. On the arc, obviously. And again, this would be more than 180 degrees. And we use 3 letters this time for major arcs. Semicircle. As you might suspect, it is exactly 180 degrees. And you can use 2 or 3 letters, but it will describe half the circle. So there will be 2 semicircles in every circle. First of all, measure of an arc. Whether you are doing a minor or a major arc, the measure is the same as the central angle that intercepts it. Okay, so the way we measure an arc is using that central angle. So you can see here, we've got 120, 120, 90, 90, 180, 30. What about the major arc in ACB? Well, again, as you might suspect, a simple subtraction problem will get us the answer of 340. All right. Congruent arcs, arcs that are the same. Same what? A couple things. They need to have the same measure. Now that's not the only thing it needs, because it needs to also have the same radius. An example here are 2 arcs that we see, AC and CD. These 2 arcs have equal measures. But as you look at those 2 arcs, the purple and the blue, you will see that they are not congruent, right? Because they have different radiuses. So this is a counterexample of having the same measure being congruent. Many times we have, through the period of this course, treated things as equivalently with therefore they're the congruent. All right, a couple theorems. Book shows 6. I'm actually going through 3. A little loud here. Arcs and angles. All right. If we have 2 arcs that are congruent, then the central angles are congruent. And vice versa. Notice this is a biconditional. Yeah? Goes both ways. So in this first example here, we have 2 radiuses that are the same, R1, R2, right? Then we know that if those arc AB and CD are the same, excuse me, then those central angles have to be congruent. All right? And we can go the other direction and say, well, yeah, if the central angles are the same, then the arcs have to be congruent as well. Okay? So either direction works with arcs and central angles. Similarly, we have a relationship between the chord and the central angle. Yeah? So here we have chord AB, and here we have chord CD. If these chords are congruent, and again, this is implying that we have the same radiuses, because you have different radiuses, then all bets are off. But if the radiuses are the same and the chords are congruent, then the central angles have to be congruent as well. And likewise, you can go back and forth there. If central angles are the same, then the chords are the same, congruent. Yeah? All right. And finally, arcs and chords. So again, notice we've done the combination, chords and central angles, arcs and angles, and then arcs and chords. So here we have a diagram, right? If AB, arc AB, is congruent to CD, right? Then the chords also have to be congruent. Again, the assumption is, again, that the radiuses are the same here, R1, R1. Okay? A couple of problems. So there we have a circle. It's got an arc measure of 102. Oh yeah, Lou Reed. That's some funky music, kids. All right, 102 degrees. Arc is 100, or the central angle is 102. So now we know that there's only so much left over, right? So I think that would be 78 degrees that's left. We divide that into 2, and that gives us 2, 2, 2, 2, 2, 2. Stay along with me, kids. So measure of angle A is 39, as is measure of angle B. All right? And I will spare you the details of this proof, which I have relabeled as the bicycle proof. There are a couple proofs in your homework. They're fairly short, though. Should be able to get through them using these ideas that if you have an arc, right, then you can assume these angles are the same, that kind of thing.